Welcome to this Itasca featured video. This tutorial will demonstrate a method to create a hybrid mesh by combining the Griddle volume measure tools, Block Ranger and GVol. The model will also be imported into FLAC 3D for future modeling. This is the final hybrid mesh imported into FLAC 3D. The model consists of a curved tunnel through a rock domain and a tunnel core. In the legend, they are named liner, domain and core respectively. This is a cutaway view of the model to easier see and show the different volume meshes. This is done by using cut planes for different range elements. The tunnel liner consists of a structured mesh, which is generated by the Block Ranger tool. The inner tunnel core and surrounding rock domain consists of irregular unstructured meshes, which are produced by the GVol tool. Even though the model consists of 3 mixed volume meshes, they are all fully conformal. In conformal volume meshes, the element faces, nodes, and edges are fully shared with all the elements connected to them. The workflow presented describes one possible approach to create the hybrid volume mesh. The workflow is divided into 3 different paths in order to generate the different volume meshes, here presented in the blue boxes, that will be imported into FLAC 3D. In the first path, we start with creating the geometry of the tunnel liner. By then using the Griddle tool Block Ranger, we are creating a surface mesh as well as a structured volume mesh for the tunnel liner. The surface mesh will then be divided into 2 surface meshes for the outer and inner part of the liner. These will be used as boundaries for the rock domain and core respectively. For the second path, we will create an unstructured but conformal volume mesh of the rock domain. Start with creating the geometry and then generating a surface mesh with Rhino's initial meshing command. The 2 surface meshes, the outer tunnel liner mentioned in path 1 and the rock domain, are now combined and made conformal. The surface meshes are then remeshed to achieve the desired parameters, for example quadrilateral dominant. Lastly is the unstructured volume mesh of the rock domain created. The third and last path will create an unstructured volume mesh for the core. We start with the inner liner surface mesh created from the tunnel liner surface. The surface mesh is made watertight, conformal, and then remeshed to achieve the desired parameters, in our case quadrilateral dominant. Lastly is the unstructured volume mesh of the core created. Throughout this tutorial, the commands will be typed in the command prompt, but you can also find the different commands in the menu bars. Start by saving the project as hybrid mesh at any desired location. Throughout the tutorial, the incremental save command will be used. The incremental save command can be helpful as it saves the model as a new sequentially numbered version. Start with the geometry for the tunnel liner. Delete all layers except the default layer. New layers are going to be created as the tutorial proceed. Create a new layer and name it tunnel liner surface. The tunnel liner will have an inner diameter of 9 meters and a liner thickness of 1 meter. The first step is to create the cross-section of the tunnel liner. To get a better view of it, you can maximize the front viewport by double-clicking on it or press the tab at the bottom. The Block Ranger tool only operate on 4 to 6-sided watertight solids. So we will create 4 separate segments that together form the cross-section. Start with creating an arc. The center of the arc is set at 0, 0. The start of the arc is at 9, 0 and the end of the arc is at 0, 9. The thickness of the liner is set be 1 meter, so the start and end of the second arc is at 10, 0 and 0, 10. Close the sides of the segment with 1 line on each side of the arcs. Type the line command. Set the start of the line to 9, 0 and the end of the line to 10, 0. Instead of retyping the command, you can simply hit enter to recall the previous command. For the other side, set the start of the line to 0, 9 and the end to 0, 10. Select all curves with Ctrl A and join them. You can join them by typing join in the command prompt or by clicking on edit in the menu and then selecting join. The first segment is done. This segment will be copied and rotated around its center to create the final circular cross-section. Select the segment and type the command rotate. Click on the copy parameter to change it from no to yes. This will copy the segment. Set the center of rotation to 0 and the angle or first reference point to 90, 180, and 270. Pressing enter in between each point. This creates 4 segments that together creates the circular cross-section. The cross-section is done. The next step is to create the direction of the tunnel. This is easier done in the perspective viewport. Create the tunnel direction by using the arc command. Set the center of the arc to 50, 0, the start of the arc to 50, 50, and the end point or angle to 0, 0. This arc will act as a tunnel direction curve for the next step, which is to create the surfaces of the tunnel liner. Change the display mode to shaded to see the surfaces more easily. Select the tunnel direction curve and use the sweep 1 command. Either by selecting surface and sweep 1 in the menu bar or by typing sweep 1 in the command prompt. For select sweep shapes, select one of the segments and press enter twice. A sweep 1 rail options window will pop up. Leave the options as default and click OK. This creates the surfaces of the tunnel liner by fitting a surface to the cross-section segments and the tunnel direction curve. The tunnel direction curve will remain selected. Continue through all segments, one segment at a time. By pressing enter, the previous command is recalled. The curves are no longer needed, so you can move them to the tunnel liner surface layer and then hide them. Do this by selecting all the curves with cell CRV. Right-click on the layer and choose Change Object Layer, and then hide them with the Hide command. Cap the geometry by selecting all poly surfaces with Ctrl-A and then typing cap. This creates 4 watertight solids for the Structured Block Ranger meshing tool. Assign the newly created geometry to the layer tunnel liner surface by right-clicking on the layer and choosing Change Object Layer. Do an incremental save. Now to the meshing process of the liner. Start by creating a new layer for the mesh of the tunnel liner and name it Tunnel Liner Mesh. The mesh is generated by first selecting all poly surfaces and then clicking on Griddle's Block Ranger icon or writing BR in the command prompt. For the mesh setting, set the maximum edge length to 1.5. This is the maximum element edge length in model coordinates. Set the parameter Generate Surface Mesh to by model. By selecting this option, the surface mesh will correspond to the external surfaces of the whole model. The surface mesh is not saved to the output file, it is only generated for use within the Rhino model. The output format is by default set to FLAC3D, which is what the resulting volume grid file should be saved as in this tutorial. Lastly, you could add an auto output name. Here the word liner is added to the output file name. The generated surface meshes can be used to create an unstructured volume mesh outside of the solids. For example, in this tutorial we will generate 2 unstructured meshes outside of the tunnel. The surface mesh will correspond to the liner's inner and outer surface, which will be used to create the unstructured volume meshes of the domain and core. Select all the meshes by writing the command cell mesh and assign them to the new layer called Tunnel Liner Mesh. By turning off the layer tunnel liner surface, only the tunnel mesh is visible. The surface mesh consists only of quadrilateral faces and it is fully conformal. The liner should be at least 3 zones thick to be able to capture bending, and as seen, the liner has 3 zones. Save the project with an incremental save, then switch to FLAC3D to start with the model. You can change the display layout. If you want the same layout as this tutorial, go to Layout and choose Wide. Import the mesh into FLAC 3D by going to File in the menu bar. Select Grid and import from FLAC 3D. Choose the file you just saved. The mesh is imported, just not visible until we create a plot. Go to Panes and choose Model. This will add and shift to the Model pane. In the Model pane, select all objects by using the Ctrl-A command. Assign the group name by using the command Shift-O or by clicking on the Assign a Group to the selection icon. Set the group name to Liner. To plot the group, go back to the Plot pane and navigate to Build Plot. Under the Category zone, select the Plot Item zone. Under Attributes, change the slot to Default. The color of the group can be changed to desired color under Color List. You can reset the view by clicking on the button in View Shift. You can also reset the view with the command Ctrl-R. Save the project as hybrid mesh at any desired location. In this case, we will save the model state at the end of the tutorial, so press No. Switch back to Rhino. Now we will divide the tunnel liner surface into two surface meshes. Start with creating two new layers and name them Outer Liner Mesh and Inner Liner Mesh. The two surface meshes are used to create the domain and core meshes, which are conformal with the tunnel liner mesh. The outer liner will be used as the boundary to the domain, and the inner liner will act as the boundary for the core. These meshes are extracted with the Griddle G-Extract tool. This is done by first selecting the surface mesh and clicking on the G-Extract icon, or by writing the G-Extract command. Select all surfaces. The default extract option for the maximum break angle is set to 89. This will separate the mesh by a break angle of 89 degrees. Keep that value, as we want to separate the caps from the liners. Select the caps and hide them with the Hide command. The outer and inner liner surface meshes are left visible. To better see the difference between these meshes, they can be colorized in random colors. To do this, select both meshes and click on Griddle's Colorize Objects icon, or write the Colorize Objects command. Select the inner liner and assign it to its corresponding layer. Do the same with the outer liner. Then turn off the tunnel mesh layer as it's not needed anymore and do an incremental save. Now to the surrounding rock domain. The next steps in the rock domain meshing process will cause changes in the outer tunnel liner mesh. But the volume meshing requires the original mesh, so we will need to duplicate it. This is done by right-clicking on the layer and selecting Duplicate Layer and Objects. Then, turn off the layers and create a new layer for the surrounding rock domain and name it Domain. Start with the geometry of the rock domain by creating a box with the Box command. It will have a width and depth of 75 meters and a height of 100 meters. Set the first corner of base to -25, 0, -25. The other corner of base or length is set to 50, 75, -25. The height is set to 75. Change the display mode to ghosted. This will make the box semi-transparent. Select the box and assign it to the domain layer and turn the layer off. Now to the tunnel openings. Turn on the duplicated outer liner mesh layer and select the mesh. Use the command dup border to duplicate its open boundaries. The boundaries will both help to create openings for the tunnel in the domain as well as act as hard edges to preserve the conformity with the liner mesh. Turn off the duplicated layer. The duplicated borders are still visible. Turn on the domain layer and do an incremental save. The openings are created by using the split command. Select a domain and write split or choose the split icon in the toolbar. The cutting objects are the two duplicated borders just created. Select the surfaces and hide or delete them to create the openings. Select the domain and create an initial mesh using Rhino's mesh command. Use the default polygon mesh option. It will be remeshed later. The poly surface is no longer needed. The command cell poly srf will select the poly surface, then hide or delete it. Turn on the duplicated outer liner mesh. The next step is to make the rock domain and liner conformal, which means that the edges and nodes are fully shared between the connected surface meshes. Select all objects and click on Griddle's GInt icon, or write GInt to intersect all meshes and make them conformal. Set the mesh type to mixed and the tolerance to 0.01. All other parameters are set to default. The duplicated outer liner mesh layer is no longer needed, so turn it off or delete it. But keep the duplicated borders for the next step, which is to remesh the domain. Select all objects, that is, the rock domain mesh and the duplicated borders. Then, remesh the domain to achieve the desired mesh parameters by clicking on Griddle's gsurf icon or by writing gsurf. Set the mode to quadrilateral dominant. Keep all other parameters as default. The duplicated borders act as hard edges to preserve the conformity with the liner mesh. The hard edges are still selected. They are no longer needed, so delete them. Start with the unstructured volume mesh. Turn on the layer with the original outer liner mesh and select all objects, that is, the meshes of the rock domain and liner, and generate an unstructured mesh by clicking on the GVol icon or by writing the GVol command. Set the mesh setting to hexahedral dominant and press enter. Make sure the output format is by default set to FLAC3D, which is what the resulting volume grid file should be saved as in this tutorial. Lastly, you could add an auto output name. Here the word domain is added to the output file name. GVol may provide a warning, as seen in this dialog, because there are open boundaries in both the tunnel liner and the domain meshes. This is alright in our cases because we made both meshes conformal and they constitute a watertight domain which can be meshed. Therefore, press yes in the dialog. Turn off the new layers and do an incremental save before we switch to FLAC3D. Switch to FLAC3D. Import the mesh into FLAC3D by going to File in the menu bar. Select Grid and import from FLAC3D. Choose the file you just saved. In the Model pane, select the rock domain mesh and set a group name by clicking on the Assign a Group to the selection icon or with the Shift-O command. Set the group name to domain. Go back to the plot pane to see the new plot. If you want, you can change the color of the domain under color list. The domain and liner look conformal. Switch back to Rhino. Lastly, the tunnel core mesh. Turn on the layer for the inner liner mesh and turn off all other layers. Change the name of the inner liner mesh layer to core. The tunnel core mesh will be unstructured but conformal to the liner. In order to keep the conformity between the meshes, the caps of the core needs to be re-meshed. The liner's surface mesh will not be affected and act as the hard edge to the core to make sure the unstructured core mesh is conformal with the structured liner when generating the volume mesh. Duplicate the core mesh's open borders by selecting the mesh and writing DUP border. These will act as hard edges to keep the conformity, as seen earlier. To make sure the core mesh is watertight, we can create two planar meshes that are bounded by the duplicated borders. The curves are still selected, so write the command planar mesh to create the caps. Now the caps will be re-meshed. Select the core and hide it with the hide command. Then, select the caps and the duplicated borders and re-mesh them to achieve the desired mesh parameters by using the GSurf tool. Set the mode to quadrilateral dominant and keep all other parameters as default. The borders will automatically be selected. Delete them as they are not needed anymore. Now we will rejoin all the meshes. Unhide the core by typing show. And join the meshes by selecting all with Ctrl-A and right join. Start with the unstructured core volume mesh. Select the mesh and use the GVol tool. For the mesh setting, the mode is set to hexahedral dominant. Make sure that the output format is FLAC3D. Lastly, you could add an auto output name. Here the word core is added to the output file name. Lastly, save the project before we switch to FLAC3D. Switch to FLAC3D. Import the core mesh to FLAC3D by going to File in the menu bar. Select Grid and import from FLAC3D. Choose the file you just saved. Go to the Model pane and select the core mesh. Assign the group name by using the command Shift-O or by clicking on the Assign a group to the selection icon. Set the group name to core. To see the new plot, go back to the plot pane. If you want, you can change the color of the core under color list. While the meshes are conformal, they are still three separate meshes with a number of duplicated nodes, edges, and faces along the boundaries of the tunnel liner. To model this example correctly in FLAC3D, it is important to combine these meshes. This can be done using a merge command that merges these meshes so that you avoid using attach conditions. Write the following command, which is specifically for FLAC3D. Zone GP merge. It returns that grid points were merged and surface faces removed. To double-check the attach conditions in FLAC3D, that is, if something is not conformal, the following command can be used: zone attach by face. It returns the value 0, which means that all the surface faces are perfectly connected to a zone on the other side. This in turn means that everything is conformal. Save the project and the model state. The project state includes, for example, settings, plots, geometry, and data files. The model state is not included in the project file. The model state includes, for example, any zones, blocks, or particles created. Additionally, it includes any solution results like displacement and stresses. Save the model as hybrid mesh. Now the model state is visible under saved states in the project pane. By saving the project, the current project state is saved into a project file. By saving the model state, the current state of all the model components is saved into a save file. Any saved model state can be restored, so it is useful to periodically save models that may take time to solve. By restoring the saved model state, you do not have to rerun all the previous model commands to review the modeling results at that point. You could also continue modeling a new construction stage or add different parameters from some saved point. The new plots are cutaway views of the model. These plots make it easier to see and show the different volume meshes. The cutaway views are done by using cut planes for different range elements, such as groups and positions in X, Y, and Z direction. Thank you for watching this Griddle tutorial. For more information about Griddle outside of this tutorial, please see the links in the description box.